guys, welcome back to my channel. So for today's video, I'm going to discuss what is the essence of mathematics. So most of the students today are struggling on their mathematics subject as they may find it is very hard to understand. But we are going to prove that mathematics is not just about numbers, but it is a part of our daily lives. So mathematics is a study of patterns, art, language, set of problem-solving tools, and also process of things. So, mathematics is a powerful tool in decision-making, and it is a way of life. Hi Miss, I'm looking for a new phone and I will use it on my online class. Which one is better, the Android phone or Apple? Wait, I'm struggling on decision making. Can you give some comments about Android phone and Apple? Ma'am, for this Android, it is good in traveling and also affordable because it costs 5,000 pesos only. But in terms of online class, you can use it in a whole day. While this iPhone, it has a good camera and has a good durability. But it costs 23,000 pesos only. But in terms of online class, you can use it 6 to 8 hours only. So Miss, I decided to buy this Android phone because as you said earlier, it's much better and it is affordable. So I buy it now. Thank you, Miss. Thank you.
Welcome to my vlog. Did you know that mathematics is an art and process of thinking? It involves reasoning which can be inductive and deductive. And it also applies methods of proof both in fashion that is conventional and unconventional. It is important tool in the field of sciences, humanities, literature, medicine, and even in music and arts. It is the rhythm of our daily activities, operational in our communities, and a default system of our culture. There is mathematics whenever we go. It helps us cook delicious meals by exacting our ability to measure and moderately control of heat. It also helps us to shop wisely, read maps, use the computer, remodel a home with constrained budget with utmost economy. Thank you for watching and stay tuned for my next vlog.
Hello guys, my name is Kyla Marie V. Barrientos from BSed Science 1101, and today we're going to know the different kinds of patterns. So, what is a pattern? Pattern is a form of design that is regular, consistent, or recurring. It is also can be found in man-made designs or in abstract ideas. Also in nature, they are patterns that are repetitive and duplicative. It is also structure regular to be modeled mathematically. So, patterns is very wide because you can see it in our daily lives. So, now that we know the meaning of patterns, let's go to the different kinds of patterns. First up is the patterns of visuals. It is often unpredictable and really never repeatable because these patterns can be found in seeds, in pine cones, branches, or leaves. It is similar but different. The second one is the patterns of flow. if you say word flow, you can always come to mind is liquid, right? The flow, it is kind of usually found in water, stone, and even in growth of trees. There is a present in also in rivers, and it is repetitive and having an undulating lines. The third one is the patterns of rhythm. The rhythm is conceivably the most basic pattern in our nature, because when you say nature, it's like our heartbeat, our breath, how we breathe, the sounds of movements that adapt in our body needs. The fourth one is the patterns of movements. When you say movement, it is you're doing some kind of actions. Just like when you're walking, when the flights of birds, the wave-like movements of worms and snakes, the pulsations of jellyfish, and etc. The fifth one is the patterns of texture. When you say texture, it is related to touch. You're touching something tangible that you can tell if it is rough, soft, cold, hot, or hard, and etc. The last pattern is geometric patterns. When you say geometric, it is like some kind of shapes like triangles, pentagon, hexagon, and etc. It is typically repeated, and regularities are. It is also in predictable manner. Geometrical patterns are usually on cacti or in succulents. So that's it, guys. I hope that you learn from me and from the example that I gave to you. Thank you for watching. See you again. Bye.
What's up, guys? It's me, Rica Atienzalianas, and I am from Bachelor of Secondary Education, major in Sciences. And for today's video, let us talk about symmetries. But before that, let us know what is symmetries all about.
Symmetry has a vital role in pattern formation. It is used to classify and organize information about patterns by classifying the motion or deformation of what pattern, structure, and processes. There are many kinds of symmetry, and the most important ones are reflections, rotation, and translation. These kind of symmetries are less formally called flips, turns, and slides. Reflection symmetry, sometimes called line symmetry or mirror symmetry, captures symmetries when the left half of a pattern is the same as the right half.
Now, let us have an example of reflection. I have here a pair of slippers. As you can see, this one is similar to this, and this one is similar to this. That's why the reflection symmetry is happened to this pair of slippers.
Rotations, also known as rotational symmetry, capture symmetries when it still looks the same after some rotation.
Now, let us have an example of rotation. I have here a ball. Whatever I do to this ball, like this, if I rotate this, it is still the same. And that's how a rotational symmetry happens.
Translational symmetry exists in patterns that we see in nature and in man-made objects.
Now, let us have an example of translation. I have here one small piece of paper and a fastener. When I put small circle here, like this, Now, we can have an identical figures, and we can call this translation. From one piece of paper, now it is have a small circle like this. Did you know that the human body and animal movement is a pattern of symmetry? Because human body is one of the pieces of evidence that there is symmetry in nature. Likewise, in animal movement, because the symmetry of motion is present when they move. Always remember that mathematics is everywhere. If we are just think deeper, we are able to see and appreciate mathematics in our modern world. That's all for today, guys. Hope you gain knowledge from me. God bless everyone.
What's up, you guys? It's your girl Yanli Landicho from BS Ed Sciences. So for today's video, we are going to define sequence, harmonic sequence, arithmetic sequence, and geometric sequence in real life situations. So let's go. But before that, let me tell you what is sequence. Sequence, it is a ordered list of number called terms that may have repeated values. One of them is the arithmetic sequence. It is a sequence of numbers that follows a definite pattern. Okay, let's watch the example. Can I buy? Yes. What? Happy. How much po? 5 pesos only. 5 pesos. Thank you. Can I buy Happy toothpaste? How much? Oh yes, what? 10 pesos. Oh, increase in 5. Okay. If in arithmetic sequence, we need to check the common difference. In geometric, we need to look for the common ratio. Okay, let's watch the example. And another example of geometric sequence, assuming that a barangay have 2 cases and it will double a day in a day. And after 14 days, imagine how many people are infected by the virus if they didn't follow the procedure of social distancing and another health protocol. The example. So example, this paper have a virus. So if people did not follow the procedure of social distancing, another person have infected. So after 14 days, there will be a 16,383 people infected in the virus. Harmonic sequence is a progression that formed by taking the reciprocal of arithmetic progression.
Patterns are found all over the natural world, from grasping a tendril of a plant, or maybe from a dew-laden web of a spider. We can see patterns as a product of living system. And yes, this is called Fibonacci pattern, or some says it's Fibonacci sequence. And some examples of Fibonacci sequence or Fibonacci patterns are the formation of a nautilus shell, or maybe the swirl of a super typhoon or a hurricane. And the most common example of all is the petal formation of a flower. And yes, that's our lesson for today, the Fibonacci sequence. And before we start our lesson for today, let's first define what is the meaning or what is Fibonacci sequence. Fibonacci sequence is a series of numbers governed by some unusual arithmetic rule. The sequence is organized in a way a number can be obtained by adding the two previous numbers. For example, the following numbers are Fibonacci sequence: 3, 5, 8, 13, 21, 34, 55. To determine the next number in the sequence, you simply sum together the previous two numbers. You can repeat this process to generate an infinitely long Fibonacci sequence. For example, if you select any three numbers in a row from a Fibonacci sequence, you'll find the same pattern. Let's define f of n as any number in a sequence, and then define n minus 1 as the number positioned just before f sub n, and n minus 2 as the number 2 positions before f sub n in the sequence. For any Fibonacci sequence, f sub n will always be equal to n minus 1 plus n minus 2. For example, let's look at a Fibonacci sequence starting 75, 120, 195. To find the next number in this sequence, f sub n, you can add 120, that's then n minus 2, to the 195, the n minus 1, and we will get 315, the f sub n. So the sequence is now 75, 120, 195, and 315. You now have a Fibonacci sequence. The Fibonacci sequence is named after Leonardo Fibonacci. He is an Italian mathematician who wrote about the pattern in his journal as he observed how rabbits reproduce. And the Fibonacci sequence worked like this. Let's say you have two segments of a specific length A and B, where A is bigger than B. If these two segments are in a Fibonacci sequence, the bigger piece divided by the smaller piece will be approximately 1.618 or 1.6. Also, if you take A's length and add it to B's length, then divide it by A's length, you will get the same number, 1.618 or 1.6. This ratio is called the golden ratio, which is the most important thing we need in order to get the nth term in a Fibonacci sequence. Here is the formula for finding for the nth term in a Fibonacci sequence, wherein x sub n stands for the Fibonacci number we're looking for, and n stands for the position of the number in the Fibonacci sequence, and the pi stands for the value of the golden ratio, which is 1.618. So hello guys, I have here a practice exercise wherein we are tasked to find what is the fifth term in a Fibonacci sequence, and in this exercise we are going to use the formula in finding the nth term in a Fibonacci sequence. So let's go. In order for us to get the fifth Fibonacci number, first we need to substitute the given data into our solution, and it will become x sub n equals open parenthesis 1.618 close parenthesis raised to 5 minus open parenthesis 1 minus 1.618 raised to 5 all over to the square root of 5. And then we will simplify the both terms in the upper, and it will get the result of x sub 5 equals 11.0890 minus open parenthesis negative 0.0901 close parenthesis all over to the square root of 5. And we all know that it is not possible to have an answer of negative, so we will make it a positive 1. So it will become x sub 5 equals 11.0890 plus 0.0901 all over the square root of 5. And then we will simplify it, and it will have a result of x sub 5 equals 11.1791 all over the square root of 5. And then the final answer we get is x sub 5 equals 4.9994. And we all know that we can't have a Fibonacci number that has a decimal point. So we will round it off, and it will give the answer of 5. So our fifth Fibonacci number is number 5. Hello guys! Thank you for listening. I hope you learned something from me. And I will leave some practice exercise in the coming up slide of this video, and you are free to answer it. And if you have some questions regarding the Fibonacci sequence, you can reach me through my Facebook account, Mark Angelo. And that's it for today. I hope you learned something from me. And that's it. God bless and stay hydrated.
Yes.
Hey guys, welcome to my channel. If you are someone new and if you haven't subscribed yet, just click the subscribe button and the notification bell so that you are always updated whenever I post a new video. Hey guys, so for today's video, we'll be talking about the different terms of set and the set. So before that, just let me wash my hair and change my clothes. And we're back. So, like I've told you earlier, we'll be talking about the different terms of set and what is set. So, let's go. Set. Set is a well-defined collection of objects. The objects are called members or elements of the set. The best example of sets can also be found or can be seen in our houses. The first example is the set of books, which is just right here. The second one is the ball pens, which we usually use when we still had classes inside our school. The third one is the kitchen organization, wherein different utensils and plates are kept or separated from one another. The plates is placed here, while the utensils is placed here, and the mugs are placed there.
We are now done discussing the set. We can now move forward and discuss
The set theory. The set theory is a branch of mathematics studies
That studies.
that studies sets or the mathematical science of the infinite. It studies properties of sets, abstract objects that encompass the whole of modern mathematics. It is introduced by George Cantor. So who is George Cantor? George Cantor. I don't know. So yeah, I'll search who George Cantor is. Wait.
Okay. Okay.
I now find some information about who George Cantor is. George Cantor looks like this. And the information about him is he is a German mathematician who founded the set theory and introduced the mathematically meaningful concept of transfinite numbers and definitely large but distinct from one another. I don't actually quite get it, but I hope you understand since I get that answer from the internet, which I know could be trusted. Um, I'll now be moving on to the ways to represent the set. There are two ways to represent the set. The first one is the tabulation method or the roster method. It is a method that uses a comma in order to separate or enumerate the set. The best example of it is if you are given with numbers 1 to 7 and you'll try to show the roster method, then you'll just use the comma. It will just look like this. 1, comma 2, comma 3, comma 4, and so on. The second way to represent the set is called set builder notation or rule method. It is a method which uses descriptive phrase in order to represent the set. The best example of it is discussed or is also discussed in my mathematics or the mathematics modern mathematics, which wait, yeah, it's just right here. The best example of rule method is the words x such that x is is a collection of vowel letters, or x such that x is a set of first 5 positive whole number. You now know or you now have an understanding the two ways to represent the set. We can now discuss or tackle the terms on set. The first term on set is the finite set. It is a set whose elements are limited or countable. The best example of it is cotton buds. We know that for every pack of cotton buds, there are only limited numbers for each pack. And yeah, we have a cotton bud just right here. And I'll just show it to you in order to prove you that there is only a limited number for each pack of the cotton buds. You see? For each pack of the cotton buds, there are only 400 pieces. 400. Limited. And that is an example of finite set. The second term on set is the infinite set. It is a set whose elements is uncountable or unlimited. The best example of it is the stars, which can be found in the sky. We know that astronomers have named many stars, but there are also other stars that have not yet been discovered or named by the astronomers, which means that the stars that we know is not the only thing present. The third one, or the third terms on set, is the unit set. It is a set whose elements It is a set with only one single element, or also called the singleton. The best example of it is just right here, like the one I'm wearing, which whatever design it could have, it still falls under the fact that it was a shirt. The fourth one is the empty set. Empty set is a unique set with no elements, or also called the null set. The example of a null set is the dinosaurs. The dinosaurs is said to have existed before Christ, meaning up to this age, meaning at this age it is no longer existing. That is why it is considered as a null set. The fifth one is the universal set. The universal set is all sets under investigation in application of set theory is suggested or assumed to be contained in a large fixed set. The best example of it is the mobile phones, televisions, appliances, which falls under the fact that it was created with the use of technology. Televisions, mobile phones, and even appliances like refrigerator. That is all for today's video. I hope you learned something from me, and please don't forget to like and share this video and comment down below if you have some suggestions for my upcoming vids. That is all. Thank you.